Good afternoon. We are talking about a project that we are experimenting with our students for digital storytelling using animation in real time with motion capture. So we use SVG, Smile, and processing. My name is Alberto Pacheco, and the other PhD professor that are working with us, Rene Cruz. We try to experiment with narratives has a cognitive tool. Just for the beginning, we experiment with some podcasts that were produced by students. They are available at YouTube. And the first videos was made just with a camera and presenting information. And later on, using storytelling. But the purpose is to explain something that is very difficult or abstract with analogies or stories. And they work, and it's a teamwork to make these videos. And we add storytelling and have a very good experience with that. Why animation? Well, it's more engagement, more easily retain student attention, is friendly because the experience is a lot of motivation doing this work for the student. And this is very important. Acting freedom, like the performance doing with a camera, is a difficult time for some students. So we try another approach. So visual storytelling, this work is experimental, and we try digital puppetry to tell stories using real-time motion capture to make an animation. But keyframe animation is difficult, time-consuming for students and teachers too. So if the other way using video streaming is very slow and in our school network, so we have a lot of trouble with that. So maybe the solution was animation. Why puppetry? Puppetry can be a great method for telling stories. This way is almost among all cultures in history, human history. So it's a way very natural for our students. This is a very logic and expressive approach to explore different things, knowledge, ideas, emotions, and information. And the student tries to demonstrate his knowledge or learning. And they share that knowledge in a very aesthetic, interactive, and multimodal way. So it's very attractive. Okay. There's one advantage with puppetry. First, experiments with the students, they don't like to act in front of a camera, but when they use a mask, they transform and start to performing very well. So we can use that effect. Like the football, many people enjoy in the stadium and transform in another person, maybe. So the problem was acting in front of a camera, but thank you for the mask effect. A learner may participate and act disguised. This is the trick, okay. An audiovisual narrative with animatic characters may unleash the persona effect. This is the other effect. From the audience perspective, they, instead of reading a text as a student, is more friendly to see a puppet acting and showing information. So this puppet can go along with the student, has many roles like a tutor, presenter, helper, or guide person. With our students, there's, from the learning perspective, we find that many of our students has a kinesthetic learning style. So they want to do something when they are learning. Learn by doing, maybe. But in our school, our traditional way of learning is more about reading or listening. So this is something different from the traditional point of view. Our approach has different scenarios or different approaches. We can use it like real-time puppetry, or we can save on a file all the animation, or we can write the data in a web page, produce a web page, or we are trying to stream the animation for a web browser. Why web? Because SVG is all we need for our approach, and it performs very well. It's the way of streaming this data was very lightweight, and we can share one machine with a depth camera to many other students, many clients, and is on real time. So we produce the puppet with SVG. Any drawing in SVG. We are explaining some of the way we create this puppet. But the motion capture is another process. The motion capture process is first we get from the camera the skeleton data. We get the points, and we transform to joint angles. And then we display and transform the puppet and display that puppet to make the animation. So this is the very synthetic way of doing our digital puppet. So we use programming language like processing, SVG, and a depth camera. In processing, we implement the joint object this way. The most important data is the point where the joint and the angle, and then the drawing of the body of the puppet. And the more important thing, or abstracting all the model, is that each joint is stored in an array. So a puppet is an array of joints. This is the algorithm to draw the puppet. We get the data. We transform that data from the kinetic skeleton to points from 2 dimensions only. And then transform these points, coordinates to angles, an array of angles. We can optionally filter that information and then update the puppet. Each joint is rotate the joint and draw the puppet. It's really small in programming code. How we organize the puppet? There are SVG groups in this way. This group contains the other joints. If we rotate something, the other objects rotate along with that object. This is the code, how we implemented the puppet using SVG. The more important process is animation. So we use Smile using animate transform to rotate, and we have to specify the point, the times, and rotation angles and positions for the each joint. But we can see that something is redundant. For each joint, we have to say each point after each angle. This is real data taken from the depth camera, and we can see a lot of noise. So we can filter that each joint movement with a low pass filter. We try different filters, and we make a very simple filter. Just average each frame, 10 frames. We average the information and works very well. This is the analysis of one example, that there are noise, but we can average the points and prepare for SVG rotation. For example, in that point, these are the 4 points on the top, the angle and the time frame. Each of these points is 10 frame average. So in time, we have almost 1.2 seconds. So we can see that it's flat. So we can join or group that points and make one rotation for that time. In SVG is how we can describe that animation. And this is another way of explaining the same. This is the data coming from the depth camera after we process it and get the angles information of each joint. So each row is about 10 frames of information, average, the average of each angle in each joint. So we have in 30 frames per second getting the data from the depth camera. And for each joint, we can see there are small variations or more different kind of variations, like we can group. We are experimenting with 3 degrees maximum for grouping. If it's below 3 degrees, we again group, and we can get more smaller data produce and angle, rotation, time. So this is preparing for SVG animation. So it's, I hope it's more clearly see how we get the animation. But when we write or make this animation, this is not able SVG to manage on this format the times. So we have to change to this way. The global duration and a percent of this each variation. So we have trouble here for streaming. For the next prototype, we found that this is not good news for streaming. So we implemented in the web page using JavaScript. Each animation is calling update function, more or less with DOM attributes. We update the information. So maybe we can have SVG streaming in the future. It will be nice to have this, something like this. But we have to implement by ourselves something that can be very easy to, without programming, if SVG supports something like this. The SVG streaming can be good for animations because you have very low weight animations, 10 times smaller than video or any other media. So it's very attractive to use this kind of animation. And this is more or less like some SVG streaming proposal or draft. So we are trying to describe this way. So how can we make the same action that we made without using without programming. You can animate this way. So we are showing the results we have. The puppets are very low, very small files. You will see a demo of them. And the streaming protocol is only 10 positions or 10 angles at each frame. So it's easy to stream that information. And we have real-time animation, in fact. And students modify some of the properties, or they draw his own puppet. So we are very confident that this is a good way to make an animation in real time. So this is only in progress, work in progress. So there are many things we have to improve, like streaming, how to manage this data for one machine with a depth camera, and any device receive the animation in real time. To improve the face recognition in the depth camera, and why not to make editing the animation produced after this process. Okay, we will show a very illustrative demo with a program working with a depth camera. The real process with the students was something like this. They produce this kind of visual storytelling for mathematics, chemistry, and different stories. So they explain something about the school topic. They designed their puppets in SVG. And you can see all the narratives in YouTube. We have a channel with these videos. Okay. This is more or less how they produce these animations. In real time, it's affecting. That's it. So this camera is low cost, like Kinect depth camera. And the students enjoy making this. We have to say stop of acting. And before this, we had some trouble to produce the storytelling narratives from our students using just video, but this is more friendly for them. That's all. Thank you.
Any questions? Rick?
So have you considered using CSS animations instead of Smile?
Did you consider CSS animation instead of Smile?
Oh, yes. It will be nice. But we use SVG because processing can read SVG files and then transform to canvas object from processing. But for the web version, maybe it will be lighter in some ways for animation. But we are mapping all the movements, and we don't know how to make this in CSS.
So one thing that you mentioned was the rotation points that you have to put in.
Yes.
You don't have to do that with CSS. You just transform margin, so that we.
Oh, it will be. We have to try that.
The rotation.
Other questions?
Thank you.
What is the main target platform? Is it actually what or is it separate?
We have the local version and different scenarios. So we want to, for mobile devices in the future, if they are SVG enabled, it can be, it works well. So maybe it can be universal for HTML, using HTML5, maybe, yes.
Other questions? I have one, or actually it's a remark. Yes. So W3C has been editing, working, well, not really a working draft, but there's a document being written dealing with SVG streaming. I don't know if you're aware.
Yes, I saw, but they don't consider the problem that we have.
Okay, I'm the editor of this document, so you can,
oh.
we can discuss it.
Oh, thank you.
Thank you.
Thank you.